Which of the following Newman projections corresponds to the following molecule? Newman projections are visual representations that look on the plane across two molecules, typically two carbons. The further molecule is represented by a circle, and the closer molecule is represented by a dot. The green circle represents the behind carbon, and the blue dot represents the front carbon. The projections around the central molecules are their substituents. Be careful to not mix the two molecule substituents. We draw the substituents relative to the eye. The eye looks across the two central carbons from either right or left. In this case, we're looking at it from the left. The dash substituents are drawn on the same side as the eye. So if the eye is on the left, the dash substituent will be drawn on the left side of the Newman projection. The wedge substituents are drawn on the opposite side of the eye. So if the eye is on the left, the wedge substituent will be on the right. Finally, the in-place substituents, so the substituents that are not wedge or dashed, are drawn up or down in the middle depending on the position of the skeletal structure. If we take our original molecule of interest and draw an eye on the left looking down onto this carbon, we have this. Looking at our front carbon, so remember that corresponds to the dot in the middle, we have the in-plane ethyl group pointing downwards. Then we have the dashed H on the left side since the I is on the left. And the wedged bromine is on the right, opposite of the I. Looking at our back carbon, which is the circle, we have the in-plane methyl group pointing up. Then we have the dashed OH on the left, and we have the wedged H on the right. Now going back to the original question, we can see that our answer that we drew corresponds with B, so that is our answer.